Hi everyone, thanks for joining this talk. My name is Malcolm Miller and I'm a simulation engineer at Deloitte Australia. Today I'm going to talk to you about development of microservices. The purpose of the talk is to show how the Julia ecosystem can be used to speed up and improve microservice development through the use of a software development kit, or SDK. It's not to show how to build a microservice in Julia. For that I want to refer you to an excellent workshop from last year's JuliaCon by Jacob Quinn called Building Microservices and Applications in Julia. So today I'll talk a bit about the challenges of developing microservices and briefly touch on our situation at Deloitte. I'll then spend the bulk of the talk talking about the SDK and the various pros and cons of using this approach. So let's get started. As before we go into the challenges, just a quick recap on what is a microservice. Hopefully you're aware of what they are, seeing as you joined this talk, but just to briefly go over it, a microservice is a self-contained, independently deployable bit of code that does one thing, has one purpose. It will be executed over a network and may communicate results over a network as well. Typically, you will have several microservices working in your overall software stack, rather than one large monolithic architecture, which was perhaps the way of doing it. They preceded microservice architectures. Microservice architectures are used by a range of organizations because they simplify deployment, and they allow microservices to specialize, either choosing the language they use or the resources they're running on. And it enables services to be scaled independently, which means you can optimize for performance and cost. So what are the challenges of developing microservices? So let's imagine that I'm developing a microservice that has one function, which is to read a data stream. That's fine, I can write that bit of functionality, but I also need to write the secondary functions that actually make it a microservice. I need to write the communications, probably a HTTP server, which the wider software stack can communicate with the service via. I need to communicate with databases and possibly other services. I'll also want to test, build and deploy that service, so I'll need the scripts for that. And hopefully I want to document it. I'll need to decide a content and style of the documentation and also deploy it somewhere. So as well as writing the core functionality, which may be the thing that I'm an expert in, I also need to understand the HTTP communications, CI/CD, and the documentation. I either need to be able to understand it or I need to copy it from another service. This will definitely take some time. It may not go wrong, but it's also possible if I'm copying that it would go wrong, that I would change something that shouldn't be changed or not change something that I should change. So there's lots of room for mistakes, and at the very least it takes time. Now, as is common in an organization, there might be multiple team members working on multiple different services. If each of these team members are writing their own versions of the communications and the build scripts, then that's going to lead to a lot of inconsistent code. It could be bad quality, but even if it's all working well, there'll still be differences in style and layout, which means that moving from one service to another will be difficult, and maintenance and upkeep will generally be made more challenging. This is made worse by a new language, especially if a language is new to developers. They'll be doing things in different ways that may not suit that language or may not work as they expect, so it's going to just take longer. Additionally, if that language is rapidly developing, different developers may understand different amounts of that language or maybe at different levels. So if someone is using the latest version of a package, another developer may be using a version that's maybe 2 weeks old, but that might be quite a big change. So there's more potential for challenges. And this is exactly where we found ourselves at Deloitte. So we are developing a digital twin framework that uses a microservice architecture. For more details on that, you can see our website or come to one of the other talks we're doing at JuliaCon, which we'll talk about how we're using Julia in that platform. But we wanted to use Julia because of its performance and because of some of the packages that are available. Unfortunately, it was a new language to the whole team. And also we have a reasonably high turnover of team members as people come on and off different projects. So to make this easier, to reduce the amount of mistakes in development and to speed it up, we developed the SDK. So the purpose of the SDK is to make developing a new microservice easy and standardize code across all services. In particular, we do this by providing interfaces for various common functions and providing code and templates. It's also to move developers one stage away from the coalface of package developments. So we do this by providing a template package and various utility packages for that common functionality. One example of such utility package is a GraphQL Interface, which I will talk to you about in a bit. before we look at the details, let's quickly discuss hosting. Julia's use of registries makes it very easy to host an SDK in a registry separate from the general registry and make this private if you wish. We use local registry.jl to create a private registry on our Bitbucket server, which is behind SSH authentication. And that works really well. It's secure, but actually, once set up, users and developers can access packages in the SDK as you would any package in the Julia general registry, just by using the add or remove commands. And also, because it's using Julia's package manager, it makes use of semantic versioning, so we can set the compat fields of our microservices so breaking changes don't automatically get pulled into services until you want them to be there. It's a very powerful and simple way of hosting, and actually compared to other languages that we've implemented this in, it's much easier. So the template package. This is how a developer would start using the SDK. They would generate a new service using this package. When they run the generate function, it will create a new folder structure for their service populated with various files. And this has just been done by using walkdir to walk through a copy directory, using regex where needed to update things like the package name. It also generates a new unique identifier for that package. You could do something very similar using package templates.jl. We just had this set up in advance before that, so we've just been doing it a bit more manually. The generated microservice contains a standardized code structure in terms of files and folder layout, and some default communication routes and HTTP functionality. It also contains CI/CD scripts that work out the box for our pipelines and automated documentation. So that means a new service is ready to deploy and run instantly without the developer having to do anything. So let's just talk through these items. So the standardized code structure. For a good microservice structure, see the talk from last year, but actually the specifics of a structure are not as important as actually just having a standardized structure. If all your services have the same structure in terms of folder and file names, it makes it so much easier to work with and maintain different services. So yeah, set it up to be what you need it to be and what you like, but you will need a project.toml file and a source that's /myservice.jl as per any standard Julia package, because you want your microservice to function like a package so you can build it. Here's an example structure that you can feel free to use. So you have the myservice top level folder. We have deploy and docs folder containing the code for package compiling and documentation respectively. I haven't detailed the scripts in this slide. We have the standard source folder, and a nice thing to do is keep the exceptions, any custom exceptions you make in a separate script. We then keep our main core execution code in a separate script. The myservice.jl is just a standard module file. What's slightly different is, and it comes from last year's talk, was the resource.jl file, which is just a submodule for your HTTP communication. Keeping that in a submodule puts in a separate namespace. Some people like that, some people don't. And finally, we have a types.jl for the custom types in the service. We have the test folder and files, and then we have kind of some very basic things like git ignore, dockerfile, makefile, readme, and sci.yaml. It's nothing groundbreaking, but having that standardized structure and layout is just super useful across the team. So that default communication contains a few things that we will have in every service. So the HTTP server and handling functionality is common. We have live and readiness endpoints, and you may have other default endpoints that you want every microservice to have. And it also has an execute endpoint. This endpoint simply calls myservice.execute. What that means is the developer only has to put their code into that function, and the microservice is all ready to go. It can be tested to be live, and it can be executed by the wider software stack without the developer having to put in any of that information. If they want to edit it and add extra endpoints, then they can, but if they don't need to, then they don't need to think about it. Similarly, with CI/CD, we have scripts that will automatically compile a system image, which is a great way of avoiding pre-compilation delays. Again, see the approach in last year's talk for that. And also we have the makefile and dockerfile and configuration YAMLs that are configured for our pipeline and for our deployment. They are generally depend on the organization you're in and what project you're in, so they may vary at a project level or at an organization level. Having documentation as part of a template ensures that your microservices are documented and are documented in a consistent way. I'd recommend using Documenter.jl, as many open source packages do, and providing a standard make.jl and index.md file in the template so that the documentation is consistent across all services generated with the template. It's also good to include the version of a template package that was used to create the microservice, just for a reference. You can also configure your CI/CD scripts to deploy this documentation automatically, which is very useful. The template for utility packages is very similar to that of microservices. It's just a cut down version. It doesn't have the building of the system image, but it still has the testing and the documentation and the layout. So I won't go into that in any more detail here. So a quick summary of a template package. It reduces the time to new microservice by including a lot of the secondary functionality in the template. This lets developers focus on the core functionality of the microservice and keeps the secondary stuff standardized across services. This ensures that CI/CD and documentation and configuration is also standardized and automatically implemented for new services. Often things like documentation are left to the last minute and then not completed, so having them set up at the start is really beneficial. Let's move on to utility packages. There are two reasons for providing packages in the SDK alongside a template. One is to provide common functionality that is used by many services, and secondly to provide a consistent interface for functionality that may be changing for various reasons. There are many reasons why you may have common functionality across your services. You may be accessing the same databases, using the same APIs, and you may find that you have a lot of duplicated code between services. It's really beneficial to remove the duplicated code and put it into a package, because that means if you want to update it, you can just do it in one place, and if you need to debug, again, you can just do it in one place. Logging and threading are two key examples where we use this. Everything wants to be standardized, and it's the same with logging. You want to have your standardized logging formats across all your services, so you can debug and understand what's going on easily. You could configure your logging in each service individually, but actually if you wanted to update it, you then have to change each service. Instead, we put it in a custom logging package that just has an initialization function. Each service uses that function when it starts up, and if we want to update the logging format or anything about it, we can do that in the package, and then just set each service to use a new version. That means that if we want to say switch from using base logging to something like Memento, we can do that quite easily and do it in one place. Yes, we still have to change each service, but only the version number of a dependency, which is much easier to do than actually change code. Threading is something else that's really important to do carefully in microservices, mainly so that we can keep communication going. Especially if you have something monitoring a microservice, if the communication gets blocked, then it may think the microservice has gone down and restart it, which isn't very ideal. Work utilities is a really useful package for simple asynchronous behavior. It sends tasks to threads 2 and upwards, or you can use something like thread pools for more sophisticated threading. So an example you could do, you could keep thread 1 for communication, send tasks that come into thread 2 so that they can run and take however long they need without blocking communication. And then if you want to multi-thread any for loops, you can send those to the remaining threads. It's worth noting that when you start manually sending stuff to different threads, you have to be careful that you're not creating clashes. If you stop using the base threading behavior, then you open yourself up to the possibility of causing some clashes in threads. It's really powerful and useful to do, but just be cautious when you do that. When deciding whether to put this common functionality into a package or into a template, it should be considered carefully, because anything you put into a template, if you want to update it later, you have to update it in every service. But as a general rule, if the function may change anyway in a service, so like you might add an extra endpoint in the routing, then you should include this in the template rather than in a package. If the functionality won't actually vary and may be updated, then put it in a package so that each microservice can just use it. The second reason for using utility packages was to have a consistent interface to changing functionality. This is particularly important with Julia at the moment. It's rapid developing, which is great. We get a lot of new features, a lot of new performance, but it can cause issues for long-running projects. And the three key reasons why this may happen are pre-version 1 packages having breaking changes more often. We want to keep using the latest version, so we have to accept the breaking changes and update things. Packages can also be superseded by other packages, either they stop being developed or new ones just come on the scene. And some packages just don't exist yet. These problems are all reducing as Julia matures, but right now we want to stay on the cutting edge. We don't want to just stick to older package versions for stability at the expense of performance and features. A couple of examples of these problems from the past year or so. And again, this is not a complaint at the individual packages. That it's great that they're being developed. It's just that the fact that Julia is rapidly developing. So AWS S3 is really useful for connecting to S3 buckets, but it switched from having to be used with AWS Core to AWS. So we had to update our microservices to switch and change, and a slight change in API that came with that. We used S3 in quite a few services, so that update took a bit of time. It's not a huge thing, but if this happens regularly and you know it's going to happen, then this is the sort of thing where an interface package can handle that change. So the microservices just use the interface package. The interface doesn't change as the developing package gets updated with breaking APIs. Data encoding was one of the first examples where we actually used the utility package. We wanted to provide just an encode and decode functions to our services to compress data, but we were playing around with different packages for this, and also new packages were coming out. But we know that if two services are using the same version of our encoding utility package, then they will be able to encode and decode without problems. And finally, an example of something that doesn't exist yet. libpql is a great package for interfacing with Postgres databases, but it does require manual writing of PostgreSQL queries, which in turn requires that developers know how to write PostgreSQL queries. It does actually say in the README that we need a PostgreSQL interface, and we do need a PSQL interface in Julia. For now, we've written a very simple interface which includes our common queries to Postgres. It's not generic enough to open source, but hopefully it will get there, and either there'll be one open source or we will be able to open source the one we're working on. It's important to consider when creating such an interface package whether it's actually worth it. That Postgres one is a good example. We've just got some basic queries that we're using for our tables, but we don't want to create an impressive private PostgreSQL interface package, because ultimately someone's going to create one in public. We actually want to, if we're going to do that, we want our one to be the public one and contribute to the open source world. It's very important to not unnecessarily maintain a private ecosystem when we could contribute to open source, which is beneficial for everyone. You get more people using it, more people adding to its features, which benefits both you as a private organization and the community. You also don't want to create a wrapper for a package that has a huge number of functions. If it's going to be more easy just to update to new versions rather than update your wrapper, then do that. And also just think how close to its final state is the package that you're considering writing an interface for. If it's basically there, then just work with the package and use that. And any small requests you can just submit as issues or pull requests yourself to that package. If it's very, very new and is going to change a lot, then you may want to consider wrapping it for the sake of stability in your project. One package in the SDK which we found particularly useful is a GraphQL interface to our server. This provides a set of functions that can be used to query the server, but it's abstracting the actual querying from a developer. For those of you who are not familiar with GraphQL, it's a query language for APIs and a runtime for fulfilling those queries. It's really useful in a microservice architecture. So if you look at this diagram, this is not using GraphQL. Here we have a bunch of microservices communicating with each other. If any microservice updates its APIs, all the microservices that use the API have to be updated. And it can create quite a nested and tangled web of communication. We can use a GraphQL server, which is the central point for all this communication. Microservices will query what they need from that server. They can also actually ask that server what the query definition is, and then only get the bits of information they need. It's a very flexible and great API language. It does mean that a lot of these services have common or similar queries which they ask of the GraphQL server. Again, this is a great candidate for a package in our SDK. So let's show you how this works. Let's call the GraphQL server the configuration manager, or CM for short. Each microservice, when executed, will query the CM to get the details it needs when it's executed. So it will be executed with an ID, and it will request the details for that ID from the configuration manager. To the microservice using the SDK, it looks like this. Using CM interface, it first of all connects to the service. This will be run once on microservice startup. And then whenever it's executed, it will just call get item details, item ID. See how abstracted that is from the developer. They don't really need to understand GraphQL or what's going on to use this. And you can do this for many APIs and really simplify the use of APIs for the developers. On the CM interface side, it would look something like this. So here we're using Diana as our GraphQL client. We have a client module variable. And when we connect, we simply store the URL and the GraphQL client object for that client in that variable. When a microservice calls get item details, it simply uses that client to query with that GraphQL string on line 12 there. This just stops users having to know, again, how to write GraphQL queries or even the address of the configuration manager. That could be stored in an environment variable, which could then be defaulted in your configuration scripts. If this query ever changes or updates, then it can then we can just update the function in one place in the interface package, and update the microservice to use a new version of the interface. So as a way of wrapping up, I want to discuss the pros and cons of this approach. So what are the advantages of using an SDK? Primarily, people can focus on what they need to focus on. They don't have to do the secondary functions that are needed for microservice, like communications and CI/CD scripts. They don't need to duplicate common functionality that you may have, like accessing databases or doing GraphQL queries. This ultimately speeds up microservice development and makes maintenance and debugging of the code much easier. All your developers are working from the same playbook. They're developing microservices in the same layout and the same standard, and it reduces duplicated code. We found it really helps speed up our development. We can launch new microservices very quickly, and we can work effectively across the team. I've already touched on some of the disadvantages of using it, but mainly we don't want to waste time building a huge private ecosystem and developing stuff privately that actually would be easy to do in the open source community and more beneficial for us as a private organization and the open source community. The SDK must be maintained to stay on the cutting edge. Sometimes it is worth having the SDK as like an interface between packages and our services, and sometimes it's not, and it's really a case-by-case basis. The other thing that's just worth bearing in mind, if you make things easier for people, then they don't have to understand as much. And that is a pro and a con. Sometimes we don't need to understand everything, but if there's a problem we want to debug, then it is worth understanding it. So just bear that in mind as you consider using an SDK, but I can highly recommend using the tools in the Julia ecosystem to build an SDK to help your organization or your team improve how quickly it can develop microservices. I'll leave that summary up for questions at the end, but thank you for listening. I hope that's been informative.